Okay, when you see here, a wave function is represented as a linear combination of two wave functions. Psi is equal to pi 1 plus 1 by root 2 pi 2. And it is given that pi pi j equal to del ij. That is, pi function is orthonormal. So it satisfies the orthogonal condition and normalization condition, both condition. Pi satisfies. So what is our check psi is normalized or not? So just to simply use the above conditions. Okay, so how to check psi is normalized? You have to find bracket psi equal to 1. When it is equal to 1, it is normalized. So to find it, we are substituting pi instead of psi. So instead of ket notation, I am writing in bra notation. For bra ket notation, we are writing psi in terms of ket notation. Okay, so multiplying both side. So pi 1, if we are multiplying both side, you will be getting pi 1 bracket pi 1. So since the given condition, pi 1 is normalized already. So the first term becomes 1. The second term, what you are getting second term is 1 by root 2 ket pi 2 bra pi 2 ket pi 1. This is equal to 0 because pi j equal to del ij, so it is orthogonal, so 0. The third term, pi 1 into pi 2, again you can say it is 0, isn't it? Pi 1 pi 1. The fourth term, is pi 2 into pi 2. So you'll be getting 1 by 2 into pi 2. 1 by 2 bracket pi 2 pi 2. Okay, pi 1 pi 1 1. So you'll be getting 1 plus 0 plus 0 plus 1 by 2 into 1. So it is not 1, isn't it? 1 plus 1 by 2 is 3 by 2. So this is not equal to 1. So what you can say, this wave function is not normalized. Not normalized. So we have got the answer for the first question. Psi is not normalized because we are checking whether it is equal to 1. We are not getting it equal to 1. We are getting it equal to 3 by 2. So what is the second one? Write down normalized wave function. Just you have to multiply by a. So here itself you can see. Just you have to multiply by a here. If you multiply by a, you will be getting a into 1 and a square. Because if you are multiplying by a, psi equal to a into pi 1 plus 1 by root 2, a into 1 by root 2 into pi 2. So you'll be getting here a square plus a square into 1 by 2. So you'll be getting 1 equal to a square 3 by 2, or a equal to root of 2 by 3. So a equal to root of 2 by 3. Your normalized wave function will be psi equal to root of 2 by 3 into pi 1 plus root of 2 by 3 divided by root 2. You will be getting 1 by root 3 into pi 2. This is the normalized wave function. And next, and C is separate problem. It is given h into pi n equal to n plus half h cross omega into pi n. Hamiltonian, h is the Hamiltonian operator operating on the wave function pi, and it is giving n plus 1 h cross omega pi 1 pi n. So h, if h is measured on psi, what it is given is h measured on pi is given. But if you are measuring on psi, what will be the measurement with what probability? Okay. So psi is given. So relate the psi with above equation. Okay. So what is given is h measured on pi n giving n plus half n plus 1 h cross omega into pi n. And what happens when it is measured on psi? And we know that pi equal to root of 2 by 3 psi 1 plus 1 by root 3 pi 2. What we have found out? Normalized wave function. What is pi 1? So what is the probability of getting the energy of pi 1? Okay. H operating of pi 1, what it gives? Substitute for n equal to 1. You will be getting 2 h cross omega into pi 1. What is this? Eigenvalue or energy, you can say. Hamiltonian energy. Hamiltonian operator operating on wave function will be giving energy into the wave function. Okay. So 2 h cross omega is the energy of the wave functions pi 1. What about pi 2? Because pi 1 and pi 2 are given in our question. Pi 2 will be getting n plus 2, n plus 1, 2 plus 1, 3 h cross omega into pi 2. So these two are energy. Now we want the probability of getting 2 h cross omega. So here, so probability, you have to be get familiar with the formula. So probability, how we have to modulus of pi 1 into psi square divided by psi psi. This is a formula for getting the 2 h cross omega energy, probability of getting this energy on measurement of the wave function psi. So how to find bracket notation? Pi 1, just you need not write anything, you just simply take the coefficient of this pi 1. What you are getting? Root of 2 by 3. Okay, so 2 by 3 square. Sorry, not 2 by 3 square. It is 2 by 3 because you are square root having 2 by 3, and psi will be giving, it is normalized. We have normalized the psi wave function, so bracket notation psi into psi will be 1. So here in denominator you will be giving only 1. So the probability of getting the energy 2h cross is 2 by 3. Similarly, probability of getting 3h cross omega is nothing but the, just you can write simply the coefficient of this pi 2. Okay, 1 by coefficient, squaring the coefficient, 1 by 3. Okay, so this is the answer for your, what will be the measurement with what probability. Okay, what will be the measurement with what probability? You are having the measurement 2h cross omega with probability 2 by 3 probability. You are having the measurement 3h cross omega with probability 1 by 3. And next, find the expectation value at h, of h only. Expectation value. So what is the formula? Keep in mind the formula for expectation value. We are making the measurement with respect to psi. Here psi into h, psi divided by psi. If it is normalized, you need not write the denominator because the denominator becomes 1. Okay, or just simply can rewrite the formula. The expectation value is nothing but summation of probability of having a particular energy into that energy value. Okay, know the real meaning of this? Summation of probability of having the particular energy into the energy value. Here you are having energy 2h cross omega into the probability is 2 by 3, correct? Plus 3h cross omega into the probability 1 by 3. So expectation value of a parameter is nothing but the probability into that value. So remember this formula. Okay, so you'll be getting 4 by 3 plus 1. 7 by 3 h cross omega will be your answer. Expectation value of h. Okay, next last one, error in the measurement in h. Measurement, error measurement. So you are measuring the expectation value of h, but how to find whether it is accurate or not? We have to find the difference del h. This is the error. Okay, the actual value minus the expected value. Del h, you are having a formula. Just remember the formula, square root of expectation value of h square plus square of the expectation value. See the difference? Square root of expectation value of h square plus square of the expectation value. So here you are having expectation value of h. You just to find the square of the expectation value, just square it. You will be having 7 sevens are 49 by 9 h cross square omega square. So to find the square of the expectation value, again the formula you can write probability of finding a particular energy into the square of the energy. So this is the formula. So what you have to square it. You have to square 2 h cross omega. So you will be getting 4 h cross square omega square into the probability is nothing but 2 by 3. And 9 h cross square omega square. You are squaring the energy into that probability. 8 by 3 h cross square omega square plus 3 or 9 by 3 h cross square omega square. Total you will be getting 17 h cross square omega square by 3. Now you can find the error in h. Square root of 17 h cross square omega square by 3 plus 49 by 9 h cross square omega square. So taking h cross square omega square outside, you will be getting h cross omega. Adding 17 by 3 plus 49 by 9. Sorry, it is not plus minus. Here, just to change the formula. This is minus. So subtract 17 by 9 and 49 by 9. Root 2 by 3. So this is the error in measuring the measurement in h.